As thought on astrobiology has progressed over recent years, along with the discovery of exoplanets orbiting stars such as Proxima Centauri and the TRAPPIST-1 system, it's becoming increasingly evident that the most common type of star in the universe, type M red dwarfs, may not be ideal for life to arise on worlds within their habitable zones. This is partly due to the rather life-unfriendly conditions these stars present early in their lives. Standing in favor of red dwarfs as systems hosting life is the fact that they are everywhere in the universe, common as can be, and they are also very long-lived, trillions of years. Standing against them at this point are a lot of things, unfortunately. Questions are being asked about tidal locking and the effects of it. Planets within the habitable zones of red dwarfs will tend to tidal lock as they are so close in to their parent star, so they would tend to present only one face towards the star in the same way that the moon only ever shows one face to Earth. This could also create extreme temperature differences between each side of the planet, and there's also the question of tidal heating itself, as the star's gravity acts on the planet. And things like weather and intense cloud formation could alter the equation of distributing heat around a tidally locked world. There are other things, such as the low output of a red dwarf makes for a very small habitable zone, decreasing the chances of any planets being present within them. But examples have already been found of this. But perhaps one of the more serious challenges for red dwarf systems to be habitable is ultraviolet light. One issue is that red dwarfs tend to flare spectacularly, and the habitable zone is very close in, bathing any planets within the habitable zone with deadly ultraviolet light. Intense ultraviolet light is typically not good for life at all, as evidenced by sunburns here on Earth. If the problem of ultraviolet light and red dwarf exoplanets proves to be a deal breaker for life, then this is bad news for life in the universe in general. It would mean that 85 to 90% of the stars in the universe could be uninhabitable for the very earliest stages of life. And that would be a shame, since red dwarfs otherwise would be well suited for life, and even civilizations later on. And there may be a limit here to how long life can exist on red dwarfs, as they may lose their water or even their atmospheres in that environment over the course of billions of years. But in a new paper, we may have a glimmer of hope in regards to the ultraviolet light. In a paper by Jack O'Malley-James and Lisa Kaltenegger, linked below, they detail that life around red dwarf stars might not only exist, but might produce an easily detectable biosignature as a result of a certain adaptation to UV. This is due to the fact that some life on Earth has actually evolved to do just that. Some life on Earth, such as certain corals, have evolved to deal with ultraviolet light through a phenomenon known as biofluorescence. This is different from bioluminescence, where the chemistry going on in an organism actually produces light. Biofluorescence occurs when light is absorbed at the atomic level and then emitted at a lower energy level. Essentially, the coral has adapted to shift the ultraviolet light into harmless visible light wavelengths and radiate it back out to get rid of it. This essentially causes the coral to glow when exposed to UV. You can take an ultraviolet light to them and they fluoresce, just like some rocks do. This leads to a familiar yet alien possibility for life on exoplanets orbiting red dwarfs. If the life on those worlds has adapted similarly to the coral to deal with the massive influx of ultraviolet light when the red dwarfs flare, a sort of bioflash, coincident with the flare hitting, might occur as a result. Inhabited red dwarf exoplanets may briefly glow or flash in response to a flare in a very characteristic way, revealing the underlying biosphere to us. If you detect a flare coming off a red dwarf and you see the exoplanet react with a momentary flash of its own, then life is likely to be the cause. The researchers point out that this may be detectable from Earth as new instruments come online in coming years, and we study new exoplanets in detail. This is just one more tool in the kit, resulting from recent thought on the subject of biosignatures from scientists. Other options for biosignatures include the vegetative red edge, where photosynthesizing plant life on Earth becomes reflective in infrared. And if we see that on exoplanets, we'd know that there were analogs of plant life there. But there may even be a better hope for red dwarf systems. We tend to be a little chauvinistic when we consider habitable zones. We live on a rather nice planet in the habitable zone of a very nice star, and we evolved here. But there may be another model for life around red dwarfs. Actually, there's probably two. Ice shell moons like Europa are a possibility, at least for providing liquid water and protection from the star. But there's another. a Titan-like world where methane-based life could get started in liquid hydrocarbon lakes. This would be low-temperature life, but it's on the table as a possibility for Titan. But in a red dwarf context, the interesting thing about Titan is that its atmosphere is transparent to red and infrared light, which red dwarfs certainly have, allowing more light to reach the surface of the planet. So Titan-like planets orbiting red dwarfs might offer an entirely new second type of habitable zone that's free from most of the problems that face liquid water habitable zones around red dwarfs. And that's just simple life. Civilizations colonizing red dwarfs is another game entirely. They are really attractive for it if you have the technology to mitigate all of the issues. You could literally set up camp at one and draw energy from it for trillions of years. There are ways we can detect the activities of such civilizations, so maybe, just maybe, instead of detecting a biosignature from a red dwarf system, we will see a technosignature instead. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently addressing the critics that say what's on screen in my videos often doesn't match what I'm monologuing about. I have no idea what you're talking about, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.